In this video, we will use trig identities to find the value of one trig function given the value of another trig function. Alright, at this point in your life, these are the three trig identities that you need to memorize, if you have not already done so. The most important one is shown here in yellow. Sine squared theta plus cosine squared theta equals 1. Memorize that right this second. Alright, pause the video, copy it down, try to write it down from memory over and over again until you can do it easily. The other two you also need to have memorized, but technically you could get these from the yellow one if you realize that all you really have to do is divide by cosine and you'll get the first one, or divide by the sine function and you'll get the second one. Anyway, they're pretty easy to memorize, even the white ones. If you recognize it, look at the white ones. They both involve some sort of a tangent function, tangent, cotangent, squared, and they both involve the number 1 being added on. And then the result is some sort of a secant function, either secant or cosecant. So, some sort of a tangent, the number 1, and some sort of a secant. And it's easy because the cotangent function is paired with the cosecant function. And then the normal tangent is paired with the normal secant function. So you should be able to memorize it fairly easily. So go ahead and start trying to memorize these. Anyway, look at problem number 16. If sine of theta equals 1/5, find the secant of theta, right? Given this particular quadrant. All right, let's think about that. Sine theta equals 1/5. Now, I know that secant theta is just the reciprocal of cosine. So if I could find cosine, then I can find secant. So let's use our trig identity to turn this value into a cosine value. So here we go. We know that the sine squared theta plus the cosine squared theta is going to equal 1. So let's go ahead and substitute 1/5 in for sine theta. So that's going to make this 1/5 squared plus cosine squared theta is equal to 1. Well, if you square this, you're going to get 1/25 plus cosine squared theta is equal to 1. Now, instead of writing 1, I'm going to write this as 25/25ths, right? Which obviously is the same thing as 1. 25 over 25 is 1. But I'm doing that because I know my next move is to subtract 1/25 from both sides. And if I do it this way, it's easy to see. 25/25ths minus 1/25 is 24/25ths. Okay, or you can use a calculator, but I'm trying to be cooler than that. So this will be cosine squared theta is equal to 24/25ths. Now, to get cosine theta, I need to take the square root of both sides. Okay, so I'm going to take the square root. Now, as soon as I do that, I know the solution will be positive or negative, so I will have to narrow that down based on the quadrant that I'm in. But for right now, I'm going to write the cosine of theta is equal to the plus or minus, alright, square root of 24 over 5. Okay, I went ahead and took the square root of 25 and got 5. Now, is it positive or negative before I go any further? So let's see. Theta is between pi and pi over 2. So picturing my little unit circle, okay, pi is right here. Pi over 2 is up here. So if I'm between pi and pi over 2, then that puts me in the second quadrant. And in the second quadrant, cosine, which is what we're dealing with right now, is negative. All right, because cosine is an x value, and x values are negative in the second quadrant. On the left of the y-axis, x values are negative. So this will in fact be negative radical 24 over 5. Now that's the cosine function. Now I wanted the secant, but I know that the secant is going to be the reciprocal of this. So the secant of theta will equal negative 5 over radical 24. Okay, so that is going to be the answer. Now I could rationalize the denominator and write this in a different form. I wonder what the calculator would say. 5 over radical 24. Oops, I missed my radical. Having a hard time here, guys. Okay, so 5 radical 6 over 12 would be another form. Alright, so that's it for that. Let's do one more. Are there any more of these? Alright, I think this is the last problem. So cotangent is equal to this. And then we need to find the sine. Well, let's try using that version of the Pythagorean identity that involves cotangent. Alright, so remember, I know that it always goes like this. Cotangent squared theta. And then it always involves the number 1. And then it always involves some sort of a secant, but cotangent goes with cosecant. So they actually made it quite easy for us to memorize. Alright, so this is going to be the identity that we could use. Now, so let's go ahead and put our cotangent value in there. So that's going to give us negative 2/3 squared plus 1 is equal to the cosecant squared theta. So that's going to give us positive 4/9 plus 1. Now I can write 1 as 9/9 if I want to, or I could just use a calculator if I'm not on this level. But looking at it this way, 4 plus 9 is 13. So this is going to be 13/9 cosecant squared theta. Alright, if you just put that in your calculator, either way you're going to get the same thing. Alright, I try to use my calculator as little as possible. I could unsquare this by doing the square root of both sides. Alright, but that's going to give me plus or minus at that point. Okay, so that's going to give me cosecant theta, alright, it's been unsquared now, is equal to plus or minus radical 13 over 3. Went ahead and took the square root of that 9 and got the 3. So, is this going to be positive or negative? Well, cosecant is just the reciprocal of the sine function. So, is sine positive or negative? Well, let's look at a unit circle real quick. Okay, we're talking 3 pi over 2 and 2 pi. 2 pi is right here. 3 pi over 2 is right here. So if theta is between these two, then that means theta is in the fourth quadrant. And sine is definitely negative in this quadrant. because sine is a y value, and y values are negative when it's below the x-axis. So it's going to be, if sine is negative, that means cosecant is also going to be negative. Alright, because it's just the reciprocal of the sine function. So let's keep that negative sign going. But let's go ahead and answer the actual question, which, by the way, should have had a theta on there. So let's go ahead and know that in that case the sine theta is going to be the reciprocal of this. So that's going to be negative 3 over radical 13. Okay? Or if you want to rationalize the denominator, it'd be 3 radical 13 over 13. And there you go, my friends. That is it. Here endeth the lesson.